My dear students, welcome back to our channel. In this video, I will be explaining the BCA third semester subject database design as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define database environment. A database environment is the complete setup where a database is created, stored, managed, and used. It includes everything that helps the database work smoothly: people, hardware, software, data, and rules. In simple words, it is like a school system. The database is the school's record book with all student information. The DBMS, database software, is like the school's office staff who manage all records. The users are teachers, students, admin staff who use the information. The hardware is the computers where data is stored. The procedures are the rules on how data should be added or updated. For example, in a college, all students' details, name, marks, attendance are stored in a database. Teachers enter marks, admin staff update fees, and students check results. All these activities happen inside the database environment. So, the database environment is everything that works together to store data safely, update it correctly, and give information whenever needed. Next important short question is: 2. Give an overview on database. A database is an organized collection of data that can be easily stored, searched, and updated. Instead of keeping information in loose papers or scattered files, a database stores everything in one place in a neat and structured way. Think of a database like a digital notebook where all information is arranged in tables, rows, and columns, similar to an Excel sheet. This makes it simple to find any data quickly. A database is managed by special software called DBMS, Database Management System, such as MySQL, Oracle, or SQL Server. DBMS helps users to add, edit, delete, and retrieve information safely. Example: in a hospital, patient details, name, age, disease, medicines are stored in a database. When a doctor enters a patient's ID, the entire record appears instantly. This saves time and avoids mistakes. In short, a database helps store large amounts of information in an organized, secure, and easy-to-access manner. It makes daily tasks faster, smoother, and error-free. Next important short question is: 3. Database analysis. Database analysis is the process of carefully studying what data a system needs, how the data is connected, and how it should be stored in the database. It is the first and most important step before designing a database. In simple words, database analysis is like planning before building a house. Just as an engineer checks how many rooms, doors, and windows are needed, a database analyst checks what data is needed, who will use it, and how it should be arranged. Steps include: 1. Identifying data, what information is required. Students, marks, fees. 2. Finding relationships, how are they connected. Student pays fees. 3. Removing unnecessary data, avoiding duplication. 4. Preparing a clear structure, making tables and connections. Example: in a college system, analysis helps decide that we need tables like students, courses, marks, and fees. It also identifies that each student can join many courses, and each course has many students. In simple terms, database analysis helps create a clean, correct, and well-organized database that works smoothly. Next important short question is: 4. Relationships. In a database, a relationship shows how two or more pieces of data are connected to each other. It tells us who is related to whom or how things interact. Relationships are important because real-world data is rarely isolated. In simple words, a relationship is like a connection between people in a family. For example, a father is related to his children, and siblings are related to each other. Similarly, in a database, data items are connected in a meaningful way. Example. In a college database, students table stores student details. Courses table stores course details. The relationship is enrolls in because a student can enroll in many courses and a course can have many students. Relationships help organize data correctly, avoid duplication, and make it easy to retrieve meaningful information, like which students are enrolled in computer science or which courses does a student take. In short, relationships connect data logically to reflect real-world scenarios. Next important short question is 5. Degree and cardinality. In a database, degree and cardinality are important concepts used in relationships between tables. 1. Degree tells how many entities are involved in a relationship. If two entities are related, it's called binary. 3 entities. Ternary. Example, in a college, a relationship between student and course is binary because only two entities are involved. 2. Cardinality tells how many instances of one entity are associated with instances of another entity. There are mainly 3 types. 1-to-1. One student has one ID card. 1-to-many, and one teacher teaches many students. Many-to-many, and students enroll in many courses, and each course has many students. Example in real life. A library database, one book, can be borrowed by many students, n. That's 1, n cardinality. In short, degree shows how many, and cardinality shows how many of each in a relationship. Next unit 1. Long questions. First important long question is traditional file processing systems issues. Before databases became popular, organizations used traditional file processing systems to store data. In this system, each department or application maintained its own set of files. For example, in a college, the admissions department might keep a file of student details, the examination department another file of marks, and the library yet another file of books issued. While this system worked in the beginning, it had many serious issues. 1. Data redundancy. The same data was often stored in multiple files. For example, a student's name might appear in the admission, exam, and library files. This wastes space and leads to inconsistency if the data is updated in one file but not in others. 2. Data inconsistency. When duplicate data is stored, it can create conflicts. For example, if a student changes their phone number in the admission file but not in the library file, the system has conflicting information. 3. Limited data sharing. Each department's files were separate, making it difficult to share data across departments. For instance, the library cannot easily know which students are currently enrolled in the college. 4. Data isolation. Data is scattered across multiple files and formats, making it hard to access or retrieve information. Generating a report that needs data from multiple files becomes complex. 5. Poor security. Since files are stored individually, it is difficult to control access. Anyone with file access can view or modify sensitive information. 6. Data dependency. The program is tightly linked to the file format. If the file structure changes, all programs accessing that file must also change, which is time-consuming and error-prone. 7. Difficulty in data backup and recovery. Managing backups for multiple files is challenging. A single file loss can affect the whole system. Example: imagine a bank using separate files for customer accounts, loans, and transactions. If a customer updates their phone number, the bank has to manually update all files. This is time-consuming and prone to mistakes. In short, traditional file processing systems are inefficient, insecure, and hard to maintain, which is why modern databases replaced them. They provide centralized, organized, and secure storage of data, solving all these issues. Next important long question is 2. Database approach. The database approach is a modern method of storing and managing data using a database management system, DBMS, unlike traditional file systems. Instead of storing data in separate files for each application, all information is stored in a centralized database, which multiple users and applications can access efficiently. Key features: 1. Centralized data storage. All data is stored in one place, reducing redundancy and saving storage space. 2. Data sharing. Multiple users can access the same data without conflicts. 3. Data integrity and consistency. The DBMS ensures that data is accurate and consistent across all applications. 4. Security. Access to data can be controlled with user IDs and passwords, protecting sensitive information. 5. Backup and recovery. DBMS provides easy backup and restores mechanisms to prevent data loss. Example: in a college, instead of having separate files for students, courses, exams, and fees, a database stores all information in one system. Students table, student ID, name, phone. Courses table, course ID, name, credits. Enrollment table, which student is enrolled in which course. Fee table, payment details of students. Here, multiple departments, admission, exams, library, finance, can access and update data simultaneously without inconsistencies. If a student's phone number changes, it automatically updates everywhere. Advantages over traditional file system. No data redundancy. Data is consistent and accurate. Easier to generate reports across departments. Secure and reliable. In simple words, the database approach is like having a well-organized digital library. All books, data, are stored systematically. Anyone who is allowed can read or update books without losing or duplicating information. It makes life easier for administrators, teachers, and students because information is centralized, safe, and easy to manage. In short, the database approach is the modern, smarter way to store, manage, and use data efficiently, solving all the problems of traditional file processing systems. Next important long question is 3. Range of database applications. Databases are used everywhere in today's world because almost all organizations need to store, manage, and retrieve information efficiently. The range of database applications is very wide, from small businesses to large multinational companies. 1. Banking and finance. Banks use databases to manage customer accounts, transactions, loans, and credit card information. For example, when you transfer money online, the bank database updates your account instantly. 2. Education. Schools and colleges use databases to maintain student records, courses, marks, attendance, fees, and library books. For example, A college database can quickly show which students are enrolled in a particular course and their grades. 3. Airlines and transport. Airlines use databases to manage flight schedules, reservations, ticket bookings, and passenger details. For example, when booking a ticket online, the database checks available seats and updates them in real time. 4. Healthcare. Hospitals use databases for patient records, appointments, medical history, lab reports, and billing. For example, a doctor can instantly access a patient's past reports using the hospital database. 5. E-commerce. Online shopping platforms like Amazon or Flipkart use databases to manage product inventory, customer orders, payments, and shipping. The database ensures that the stock is updated and customers see correct product availability. 6. Government and public services. Government departments use databases for voter registration, tax records, driving licenses, and social welfare programs. For example, Aadhaar is a huge government database storing details of over 1 billion citizens. 7. Telecommunication. Mobile networks use databases to manage subscriber details, call records, billing, and plans. In simple words, a database application is any system that uses organized data to make life easier. Wherever data needs to be stored, updated, or accessed efficiently, databases are used. Example. Think of a school. Instead of maintaining paper records for students, teachers, and fees, everything is stored in a single database. Reports like top scorers, fee defaulters, or attendance summaries can be generated instantly. In short, databases are everywhere: banks, schools, hospitals, airlines, online shops, and governments, making information management fast, accurate, and reliable. They form the backbone of almost every modern system. Next important long question is: 4. Advantages of database. A database is a powerful system to store and manage data efficiently. Compared to traditional file systems, databases offer many advantages that make them essential for organizations of all sizes. 1. Reduced data redundancy. In a database, the same information is not stored multiple times. For example, in a college database, a student's details are stored once and used by all departments like admissions, exams, and library. This saves storage space and avoids confusion. 2. Data consistency. Because data is centralized, all departments see the same information. If a student updates their phone number, it automatically updates everywhere. This ensures accuracy and consistency of data. 3. Data sharing. Databases allow multiple users to access the same data simultaneously. For example, the college office, teachers, and library staff can access student records at the same time without any conflict. 4. Improved data security. Databases provide user-level security, so only authorized users can view or modify data. For instance, only the finance department can update fee details, while teachers can only access marks and attendance. 5. Easy backup and recovery. Databases make it simple to back up data and restore it in case of loss. For example, if a server crashes, the database can be quickly restored from backup, preventing data loss. 6. Better data integration. A database integrates information from different departments, making it easier to generate reports. For example, the college can generate a report of students who have paid fees and have good attendance. 7. Efficient data retrieval. Databases allow quick searching and sorting of information. For example, Finding a student's record among thousands of records takes just a few seconds. Example: in a hospital, a database stores patient records, doctor schedules, lab reports, and billing. Doctors can access patient history instantly, the billing department can generate invoices automatically, and lab reports are linked directly to patient records. In simple words, a database is like a smart digital notebook where everything is organized, safe, easy to share, and quick to find. It reduces mistakes, saves time, and keeps information reliable. In short, databases save time, avoid errors, enhance security, and make information management easy and efficient, which is why they are used everywhere today. Next important long question is 5. 3 schema architecture. The 3 schema architecture is a way to design and organize a database so that it is flexible, secure, and easy to manage. It separates the database into 3 levels: internal, conceptual, and external, each serving a specific purpose. 1. Internal level, physical level. This is the lowest level, showing how data is actually stored in the database. It deals with storage structures, indexing, and file organization. Users don't see this level, it is handled by the DBMS. Example: how student records are stored on the hard disk, the order of fields, or the indexes to speed up searches. 2. Conceptual level, logical level. This is the middle level, describing the entire structure of the database logically. It defines tables, relationships, constraints, and data types without worrying about physical storage. Example: a college database may have tables for students, courses, and enrollment, and relationships like students enroll in courses. 3. External level, view level. This is the top level, showing what data different users can see. Different users can have different views according to their needs, without affecting the main database. Example: teachers may see student marks and attendance. Finance staff may see fee details. Students may see only their own marks and attendance. Advantages: data independence. Changes in one level do not affect other levels. For example, changing the way data is stored physically won't affect the user view. Better security. Users see only what they are allowed to see. Simpler management. DBAs can manage large databases efficiently without disturbing users. In simple words, think of it like a building. The foundation, internal, holds the structure. The plan, conceptual, shows all rooms and connections. The rooms people enter, external, show only what they need to use. Example in real life. In a hospital, the internal level stores patient files, the conceptual level defines patients, doctors, and appointments, and the external level allows doctors to see only their patients' data while accountants see billing information. In short, the 3 schema architecture makes databases organized, flexible, and user-friendly, separating how data is stored, structured, and viewed efficiently. Next important long question is 6. ER model, entity relationship model. The ER model is a conceptual way to design a database. It helps us visualize and organize data before actually creating the database. The model uses entities, attributes, and relationships to represent real-world information in an easy-to-understand format. 1. Entities. An entity is anything we want to store information about. It can be a person, place, object, event, or concept. Example: in a college database, student, teacher, course are entities. 2. Attributes. Attributes are the details of an entity. They describe its properties. Example, a student entity may have attributes like student ID, name, age, and phone number. 3. Relationships. Relationships show how entities are connected. Example, in a college, a student enrolls in a course and a teacher teaches a course. These connections are relationships. 4. Primary key. Each entity has a unique identifier called the primary key to distinguish one record from another. Example, student ID uniquely identifies each student. 5. Degree and cardinality. Degree shows the number of entities in a relationship, binary, ternary. Cardinality shows how many instances of one entity relate to another, 1, 1, 1, n, m, n. Example of an ER model in college. Entities, student, course, teacher. Relationships, student enrolls in course, teacher teaches course. Attributes, student has student ID, name, course has course ID, name, teacher has teacher ID, name. Advantages of ER model. Easy to understand and visualize. Helps in designing the database correctly. Reduces errors and redundancy. Acts as a blueprint for creating tables and relationships in DBMS. In simple words, think of the ER model as a map of your database. Entities are places on the map, attributes are details about the places, and relationships are the roads connecting them. In short, the ER model helps convert real-world data into a structured database design, making it easier to build, manage, and retrieve information accurately. It is the first step in designing any database.